Hi, this is Boston University EC544 project on secure wireless communication over RA for data acquisition. The receiver begins by generating a random username, key ID, and passphrase, which the opposing party is aware of by passing it all to a shelled alias file. The receiver produces a private 2048-bit modulus RSA key. From this private key, they generate a corresponding public key. This is tied to their corresponding username and fingerprint. The public key and its public parameters are sent to a public key server. Next task is to fetch tweets from Twitter using secure API using Python. The input keywords and input number of tweets are put into the parameter query to grab the message from the most recent tweets. Once the URL is created, the API interface will attempt to connect to the endpoint. The BRL token is the most beneficial token to use for this project. With a successful connection to the endpoint, the tweets are pulled and stored into a list of Python. Each item in the list consists of following parameters: tweet ID, author ID, text, and date created. Now to encrypt the plaintext, we need to retrieve keys of Bob using his unique ID, which he already published on Ubuntu key server. The sender here retrieves the public key and use it to encrypt the message, generating a signed and encrypted PGP ciphertext message. So a pseudo random functions mimics to generate all of these variables and keys. If we run the script encryption, which we have written in Python, this will run thrice in order to generate a signature key, an encryption decryption key, and a final key, where the ID and public key is published on Ubuntu key server. Here we can see the PGP message which we have generated using the encryption module. Now the sender runs the script which formats the encrypted message such that it can be transmitted over RF. So we have written a Python code for doing this. This will convert the file. We used delimiters before the start and end of message to distinguish the message at receiver's end. So here you can see the tx.txt file. Also it is saved in the directory. So that can be directly picked by our GNU radio. GNU radio will read this particular file to transmit, and for transmission we used GNU radio as its open source software development toolkit and provide signal processing blocks to implement software radios. On hardware side, we tested the system with HackRF and BladeRF micro, which is wideband MIMO transceiver, and the receiver is RTL SDR. It is a burst powered portable and has a maximum quadrature rate of 10 megasamples. GNU radio integration is provided via GR Osmo SDR block. To process digital signals, there are several stages: filtering, correction, analysis, deception, as processing blocks are written in C++ and Python in the backend. We used GMSK modulation based on MSK, which is itself in a form of continuous phase frequency shifting. And here we can see waterfall plot and scope plot and slider to change frequency and gain settings. If in case this method failed to transmit data with efficiency or there are any hardware failure, we had the backup to use RF signals over IP and not actual antennas. The use of IP-based transport eliminates the complexity of deploying actual radios and transmitting RF over the air. The receiver then begins to monitor the RF channel as per our GNU radio specification, receiving data over the air and populating an RX file with the message which is encoded at pre-agreed frequency. So with the use of threading, the monitoring stops over the RX file has been populated at least once, so likely much more than that. Here you can see the received message. The received data is now need to be filtered, but here we can see like it is received multiple times. Next we run a program that takes these received bytes into one clear ciphertext. The received data is sent to the processing module to filter the repeated ciphertext using delimiters. So here sender fulfills their role, and Now we can see we have recovered ciphertext in desired format that we can further process for decryption using the private key and ID which we have already generated for allies. Finally, using cryptographic modules, we decrypt the ciphertext using the private key into a suitable form and for the user to read, and voila, we have our plain text over here. So this is the recovered tweets which we wanted to securely transmit, and we have that data. Thank you.